Today we're going to talk about sign charts for polynomial functions. So first of all, what is a sign chart? A sign chart is just a number line that tracks where the function's y value is positive or negative. So it's just a number line that decides when the function has a y value, or that shows when a function has a y value that is either positive or negative. That would mean it's showing when the graph is above the x-axis or below the x-axis. You may see a sign chart referred to as an f of x number line at some point in your math career as well. So let's make a sign chart for this polynomial function. I've given you a graph, and so the first thing we need to do is create a number line. I have just gone from -5 to 5 on my number line so that I can, only because that's all I need to be able to see this graph right here. So from here, I have to think, what are these important points that should go on my number line? So the important points should be where the changeover occurs from negative to positive y values or vice versa. So those points would be your x-intercepts or your zeros. That's where your graph would change from having negative to positive y values or vice versa. So that's the first thing that we'll do, is we'll plot all three of our x-intercepts on our number line. From here, I'm going to look at intervals on the graph and try to decide if those intervals have negative y values or positive y values. So if I look at this first interval prior to -3, I've noticed that all of those y values are negative. So that means there's going to be a negative sign written in this interval prior to -3. After -3 and before 0, we have y values that are positive. So there's going to be a positive sign in between -3 and 0. Between 0 and 2, we have y values that are negative. And then also after 2, we have y values that are negative. We still want to split up these two intervals, even though they both show a negative y value and then an additional negative y value, because there's one important point right here where we do not have a negative y value. We have a y value that is exactly equal to 0. So we want to make sure to distinguish those important points. So when we have a graph, this isn't too difficult to do because I can look at the picture and track when my y values are positive and negative. This becomes a little bit more difficult if we don't have the graph in front of us. So what are our options if all we have is the equation and not a graph? So there are two options that I want to talk about. You can decide which one of these options you feel is better for you. The first option is to plug in values to the equation, and the second option is to use our knowledge of the graph itself. So let's take a look at that first option. So we have this function here, and we would like to create a sign chart for that. So the first thing that I have to do is make my number line, and then I have to plot my x-intercepts or my zeros on the number line. So this function is factored for me, so this isn't too hard to plot my zeros. I have a 0 at -3 and +4. So I'm going to plot those numbers. From here, we are going to think about whether the intervals produce positive y values or negative y values. Okay, so for example, if we look at this interval after 4, okay, and we plug in a number that is bigger than 4, okay, maybe 5. If we think about what that comes out to be, if I'm plugging in 5, if we think about this result, we don't even really need to know what the final result is. This is not too hard to calculate. That's -16. But the 16 itself doesn't matter. It's just the fact that it's negative. So we notice we have a negative times a positive will give us a negative answer. So we're taking a number in this interval. I chose 5. We plugged into our equation for x, and we decided whether the outcome was positive or negative. Let's try that for an interval in here. So we need to pick some number between -3 and 4. So maybe 0. 0 tends to be kind of a nice, easy number to pick. So let's plug in 0 and let's see what we get. Okay, so again, I've chosen to plug in 0. Let's make sure we get that negative outcome. So let's see, -2, and then +3, and then -4 squared. So again, I don't have to calculate this. I just need to know whether the result is positive or negative. So we have a negative times a positive times a positive, right? -4 squared would be positive. So again, I don't really care what the outcome is. I just care that it's negative. And that allows me to write a negative sign up here. We will do that one more time with a number smaller than -3. So maybe we plug in something like -4. Okay, so let's plug in -4. So -2, let's see, -4 plus 3 is -1, and then -4 minus 4 is -8. So again, I don't care what the outcome is. I don't actually have to calculate the number. I just want to know whether it's positive or negative. So I've got a negative times a negative times a positive, right? -8 squared would be positive. So negative times positive would be a positive outcome. So we are picking numbers that fall in the interval. Okay, notice I did not pick the zeros themselves. I picked numbers in the interval, plugged into the equation, and decided whether the outcome was positive or negative. The actual number that you get out when you plug in isn't as important as the sign, right? That we're making a sign chart. All right, so that is one option. Let's take a look at the next option. Okay, so the next option is to use our knowledge of the graph of f of x. So it's almost like we're picturing what the graph will do, how it will behave, and we're using that to help us. So we're not calculating anything, we're using our knowledge of how the graph behaves. So I'm going to start the same way. I'm going to make a number line, and I'm going to plot my zeros. Okay, that will start the same way no matter what. So I like to start on the right side. Okay, so when I think about the way the graph will look, and I think about the end behavior of the graph, I know that this has to be a negative. That's because as x gets bigger and bigger and bigger, as x gets more and more positive, right, as we have a really, really, really big positive x value, that means we'll have a positive times a negative gets us the result of a negative. So if we think about the end behavior of this graph, if we have a negative leading coefficient, our end behavior on the right side will be negative. If we had a positive leading coefficient, then our end behavior on the right side would be positive. So our leading coefficient will dictate this end behavior. So I will know that this section should be negative. From here, I'm going to keep working backwards. So when I think about this next section, I'm actually going to focus on the 4 for a second, and I'm going to go back to the equation. This factor has an even multiplicity. It has a multiplicity of 2. That is an even number. That means the graph bounces at 4, meaning it stays on the side of the x-axis that it was on before. So if it was negative on this side of the 4, it should remain negative. It should remain below the x-axis because we kind of bounce off the x-axis. We remain on the same side when we have an even multiplicity. For the last section, I'm going to focus on the -3. -3 has an odd multiplicity. That has a multiplicity of 1. That means the graph will cross the x-axis meaning it will flip to the positive side. So based on the behavior at each x-intercept, whether it crosses or bounces, and based on the end behavior on this right side, I can fill in my sign chart just based on my knowledge of the graph instead of having to plug in numbers. The options are up to you. It really depends on what you feel more comfortable doing. You are welcome to use a combination of both options, both methods, but you want to be able to create a sign chart from an equation without having the graph to look at. Thanks for listening.